All right, in this video, we will continue finding the discriminant, but we also will finish solving using the quadratic formula. So just you might want to pause the video to get this first example copied. 2x squared plus 5x plus 3 equals 0. It is already equal to 0, so we're good. And I just rewrote the quadratic formula here so that we have it all in one spot. I'm actually going to do the discriminant first. 5 squared minus 4 times 2 times 3. See what kind of solutions we're getting. So our discriminant is 1. Oh, that's kind of messy. Hold on. One is a perfect square. So positive perfect means 2 rational solutions. So we will approach different type of solving methods based off of that discriminant. So when we solve and we go to plug it in, we already found the discriminant. So if finding the discriminant is part of your work, you don't need to do it all over again and plug it again in here. And honestly, I would recommend doing that simplifying anyway. So we'll do -5 plus or minus the square root of 1, because we already found that inside part, over 2 times 2. We do know what the square root of 1 is, so we're going to break this into 2 fractions. -5 plus 1 over 4, or -5 minus 1 over 4. And we're going to finish simplifying because we can. So we get -4 over 4, or -1, and then we get -6 over 4, which simplifies into -3 over 2. And because of this type of solutions, this one also could be solved using factoring. When you get the 2 rational. Okay, so our second equation, I'm going to do a few things for this one first. First, get this equal to 0, so I'll subtract the 4x and the 6. I'm going to find my discriminant. This comes out to 88. Positive, but not perfect. So we get 2 irrational solutions, which means we are going to keep our answer in radical form when we get into the formula. All right, so now let's plug everything into the quadratic formula. Again, we already found the inside of the radical, so we don't have to do that again. Now, because square root of 88 is not a perfect square, we're going to pull this off to the side and simplify the radical, just like we did in our last unit. And you do this the way you feel comfortable, whether it's the factor tree or finding the perfect square that goes in. We are only working with square roots here, so we're looking for pairs of numbers. So the 2's come out, and we get 2 square root of 22. And we're going to put that back in. Now, there's a couple ways you can do this next step. You want to make sure that everything on the outside gets simplified. So it might be worth splitting it into 2 fractions and simplifying each of those parts. So that you don't forget to simplify a certain part. And then there's 2 ways that we can write this. You can keep it just like this, plus or minus does mean the two answers that we were looking for. A lot of times, because you'll simplify it and keep everything together in one big fraction, you might leave it like this. Or another option is to split it into two separate fractions. We are going to leave it in the radical format. So this is just an alternative way to write it, just like we had the two solutions up here. The plus or minus is fine to leave it that way, but it's just showing you that really there are two answers, one with a positive and one with a negative. All right, we just want to look at a few more examples here, just to kind of see the different scenarios that we could come up with. Our third example is 4x squared equals 8x minus 13. We should get this one equal to 0. So I'm going to subtract 8x from both sides and add 13 to both sides to get the equal 0. Our discriminant is negative 8 squared minus 4 times 13. This is going to come out to be negative 144. Anytime you get a negative, it will be either two imaginary or complex solutions. So we should expect to see I in our final answer here. So we'll do x equals negative 8 plus or minus the square root of negative 144 over 2 times 4. Now, there's different things that happen here. The negative is coming out as the I. If this is perfect square, then that will come out as well, and if not, you will simplify the radical. So we get plus or minus 12i. I just want to kind of highlight that. So this negative sign is coming out as an I on the outside over 8. Now, similar to the last example, you can separate into two fractions to make sure that you simplify completely. Okay, so this is one option for your answer. Or you can just say, okay, what's something that goes into all three of those numbers? You can divide everything by 4 and get 2 plus or minus 3i over 2. The answers look different, but they're really the same. The plus or minus will again represent the fact that you have the two answers. So I'm just leaving those both as plus or minus instead of writing them out as two answers. All right, two more examples. This one's very similar to the last one with a slight difference. So our discriminant is negative 1. You might want to put that 1 in there just to make sure that you plug everything in correctly. This also comes out to negative, so we'll have 2 complex, but 39 is not a perfect square, and it doesn't actually simplify either, but we'll talk about that. So we'll put in other information. If you were to break down 39, you can do 3 times 13, both prime numbers, no pairs, so you can't pull anything out except for the negative sign. So you keep the 39 in, but you bring out the negative as an I. And there will be different types of solutions for this. You might be able to take out just a part of the square root or the whole thing like the last example, but this ends up being your final answer here. There's nothing you can simplify since we didn't pull out any numbers. And then the last example probably isn't one that you necessarily would want to do with quadratic formula. if you were to realize the kind of factoring you would do with it. So we're going to do 12 squared minus 4 times 4 times 9 to get our discriminant. When you plug this in your calculator, the discriminant comes out to be 0, which means we have one real rational solution. And if you think about it, when we plug it in, this eliminates the whole plus or minus with the square root, which is why we only get one answer, because when we have plus or minus square root 0, that part disappears. So all we get is negative 12 over 8, which would then simplify into negative 3 over 2. So if you're ever in doubt about how many solutions you have and what type, you could finish doing this entire process with the quadratic formula. The goal, if you're just focusing in on the discriminant, is to be able to tell in advance the type of solutions based off of your answer here. And then you kind of know what to expect once you go through the quadratic formula process and what kind of answers will be acceptable for each part.